The second half of lesson 6.3 is titled Composition of Functions. Given two functions, f of x and g of x, the composition is known as h of x equals. We're going to write f and then parenthesis g parenthesis x with a double parenthesis on the right. And we read this as f of g of x. So f of g of x. One thing that we want to be clear on, this is not multiplication. Composition is different. When evaluating composition, you want to work inside out. And what I mean by that is that the inside function is g of x. So if you substitute a value in for x, the output that you would get actually becomes the input for the outside function f of x. And that's what you would plug in for the other equation. The final output is the final answer. Please take a moment to write all that out, and let's move down to the examples down below. Down below, we have 7 examples related to the two functions f of x and g of x. And this is all we have for the rest of this page. So take a moment, write all this out, give yourself some space in between, pause the video, and then when you're ready, press play, and we'll walk through each of the examples. All right, here we go. Let f of x equal 3x minus 8 and g of x equal 2x squared. Example A, evaluate f of g of 5. So the plan is to work inside out. That means we're going to first start by evaluating g of 5. That will be our step 1. And to do function notation, we're just going to substitute in the value for x into the equation. It's 2 times x squared, which means this is going to be 2 times 5 squared. Thinking order of operations, we know that we have to evaluate 5 squared first, so that's going to be 2 times 25, and that output is 50. That's our answer for g of x. But the definition for composition is the output of one function becomes the input for the other function. So in step 2, to figure out what f of x equals when x is 50, we're going to evaluate f of 50. So now up in the f of x equation, it's 3x minus 8. We're going to do 3 times 50 minus 8. Order of operations, I don't need that parenthesis there, sorry. Order of operations, we're going to do 3 times 50 first, and that's 150. If we subtract 8 from that, we get 142. This is the answer for the composition f of g of 5. In the next example, I just reversed the order for the composition. Now we're going to evaluate g of f of 5. But it doesn't mean we're going to get the same answer. So watch this. If we're going to truly work inside out, we need to evaluate f of 5 first. That means in the f of x function, we're substituting in 5 for x. And that gives us 3 times 5 minus 8. 3 times 5 is 15, and 15 minus 8 is 7. That's the output for f of 5. But then by definition, that output becomes the input for the other function, g of x. So in step 2, we'll evaluate g of 7. G of x is 2 times x squared, which means we're going to evaluate 2 times 7 squared. 7 squared is 49, and 2 times 49 is 98. The composition g of f of 5 equals that end result of 98. We can do a composition where the function stays the same, f of negative 2. Now, order of operations, we're going to work inside out on this, so we're going to evaluate f of 2, all by itself. If f of x equals 3x minus 8, 3 times negative 2 minus 8 would give us negative 6 minus 8, which equals negative 14. Again, that output now becomes the input for that outside function, which is f of x once again. We're going to substitute that value in for x and evaluate f of negative 14. And again, we just repeat the process. Plug in negative 14 for x in that f of x function. 3 times negative 14 minus 8. Well, 3 times negative 14 is negative 42. And if we subtract 8, we end up with an end result of negative 50 for the composition. For the last one in this row, I want you to try. See if you can evaluate g of negative 4. When you think you have it, press play again and see if you got a match. Please pause the video now and try g of negative 4. Were you able to come up with 2,048? G of negative 4, if you square negative 4, remember you get positive 16 times that outside coefficient of 2 would give you 32. That output then, you square 32 again and you get 1,024. Times 2 gives you 2,048. The last three examples are what's known as general composition. What happens here is we start with an x and we'll have x in our final answer. So here's how it works. We still evaluate inside out. G of x is going to be step 1. And by definition, the only thing that we know about g of x is that it matches the equation 2x squared. Now that's your technical output, and that becomes the input for f of x. This means we're going to substitute in, get this everybody, 2x squared for f of x. So wherever we see just x, we have to plug in this entire thing in place. Now f of x is 3x minus 8. That means we're going to take 3 times 2x squared minus 8. So wherever we saw x, we plug in our new value as a substitution. And then we simplify. 3 times 2x squared becomes 6x squared minus 8. Notice here there are no like terms. If we're trying to subtract, we don't have anything that matches exactly. Therefore, 6x minus 8 is the general composition for f of g of x. Watch what happens when we reverse this. This is going to get a little crazy on us. G of f of x. Again, we work inside out, and we start off pretty simple. F of x, by definition, is 3x minus 8. That seems fine and good, but remember, that's now our input for the g of x function. So we have to substitute that in where we see x. That's our step 2. If we substitute in 3x minus 8, we have 2 times x squared, which means we're going to have 2 times 3x minus 8 squared. And we have to simplify this. This means we're going to have to write out 3x minus 8 twice and FOIL it. Who would have thought that was going to happen? Let's go ahead and do that. 3x minus 8 times 3x minus 8. Now, as we take a look at our order of operations, let's evaluate that product first, and then we'll distribute the 2 in at the very end. 3x times 3x becomes 9x squared. 3x times negative 8 is negative 24x. Notice we get another negative 24x for the inside terms, and then negative 8 times negative 8 becomes plus 64. The 2 terms in the middle don't cancel this time. We end up with 2 times 9x squared minus 48x plus 64. And now to simplify and get rid of the parentheses, we're going to distribute the 2 in and just double all of our coefficients. The composition for g of f of x becomes 18x squared minus 96x plus 128. That's quite a general composition. And last but not least, we can do a general composition with the same function, f of x. Same rules apply as before. We're going to start with the inside f of x. The equation up above is 3x minus 8. That entire output now, once again, just like all the other ones, becomes the input for, once again, f of x. We're going to substitute that in the parenthesis. And that means we're going to plug all of this in where we see the x in the f of x equation. We'll leave the 3 out in front, and then instead of x, we're going to substitute in 3x minus 8 in its place. And then we get another minus 8 after. Now, nothing cancels out here. Watch what happens. If we distribute the 3 in to eliminate the parenthesis, 3 times 3x is 9x, and 3 times negative 8 is negative 24. That allows us to get rid of the parenthesis and drop down that last negative 8, and we can combine like terms for a final result of 9x minus 32. And this is the second half of lesson 6.3.